Okay, hello guys. So my last stream ended as a disaster because Emacs stopped working, and I fixed my setup yesterday. Spent 2 hours trying to get it work with Haskell language server, with the Haskell engine, then went back to just some plain Haskell mode. About fixing that, I also was able to make GHCID work. So now I can run GHCID -c cabal REPL inside of the exercise folder and have it working and checking what I'm writing. So that's good. Honestly, the Haskell mode type checking here is a little slow, so I wish I could maybe disable it and just use GHCID. This is hard to say. Yeah, I don't know. So anyways, I'll start back with these exercises, which looks very interesting and probably challenging. So, number one of the restrictions around classes that we occasionally hit is that we can only have one instance for a type. There are, for example, two good candidates for a monad instance when we think about integer. So we have both sum and product. So the first task is to write a new type around integer. Let us choose which instance we want. So we have this new integer, which takes a type of kind integer monoid. This one is, as we saw yesterday, this type using DataKinds is automatically promoted to a kind, and these values are promoted to types. So we can say that this new integer takes type A of kind integer monoid. So it's to say that it takes either a sum, this sum, or this product type. And then this is what it's returned. All good so far. So now we can write the two monoid instances for integer. Let's try. So we can write the instance for sum. It's new integer 0. Unexpected type new integer sum. Oh, you know what? Gonna open the cool retro term, which has bigger font anyways. It looks cooler, like I'm in a movie, hacking the FBI or something like that. Okay, yeah, it's complaining. Unexpected type new integer sum. Oh, that's interesting. Wait. So, unexpected type new integer sum in the class declaration for monoid. A class declaration should have the form class monoid A, where this is what I'm doing. So let's go back to the chapter explanation, because I think probably I'm misremembering some stuff. So this one compiles fine. Let's see. I feel this DataKinds stuff, it's really confusing for me. I have to get back into the mindset, otherwise it's just confusing. So we have a new type, new integer, which is parameterized by another type. What if I do this? Oh. This is obviously an instance. Okay, it's late, I'm tired. Sorry. Okay, I'm gonna get a different error. So I want to keep GHCID open because it's much faster than this. Oh, we need semigroup too. So we can write instance semigroup new integer sum where new integer a new integer b is equal new integer a plus b, which is good. Can I have no idea how this works. Yeah, no. Okay, and then we can write the same thing for the product. New integer product. New integer a, new integer b equals new integer a times b. And then we have an instance. Anyways, I think that with DataKinds enable, I'm not forced to put the tick before the type, because I think GHC is smart enough to know that I'm talking about the type, not the value. But I think I get a warning. Yeah, okay. But still, it's just a warning and not an error, so it's good. Okay, so as a quick recap, we created this new type, wrapping an integer, and we are using this phantom type here to be able to parameterize the classes, the instances. So then we can have two instances for integer, while normally it's only possible to have one. So we use this promoted data type, which becomes a kind integer monoid, which has two types, sum or product. And so we can parameterize this new type using the kind integer monoid, meaning that we can either pass sum as a type or product as a type, which we're doing here, writing the instances. Why do we need flexible instances to do this? Because we are wrapping a concrete type and not a type variable. Okay, two. We can write a type that is of kind type, but has no value level member. So you usually call this type void. So yeah, a void type has no constructors, has no values. So it's not possible to produce a value with this type. It has zero constructors. If we promote this with DataKinds, can we produce any types of kind void? I don't know. I'm assuming no, because we have no constructors, so we have no types. We can try. We can try. Let's create a void integer. This is good, and I think we won't be able to do anything like this, because what if we want to write a semi-group instance for this? And now what are we gonna pass here? Void, sorry, without the space. Void integer, but there is no constructor, so there is no type. We can do this. So yeah, I feel like this is useless, or maybe it's as useful as void is. So maybe there are some cases in which where it's useful. I'm gonna answer no. Uh, B. What are the possible type level values of kind maybe void? I already took some notes here last time. So maybe it's a type constructor, which takes a type, returns a type. So our promoted, maybe it's a kind constructor, which takes a kind, returns another kind. Void is just a type or just a kind. So I feel like we can only use nothing, but not just. Let's try. Uh, okay. Uh, let's just do this for now. I mean, we don't have to write a correct instance. I just want to an expected type, maybe integer. Uh, again, am I going to do this error all night long? I hope not. Yeah, okay, so this compiles, but obviously I don't think we can't do anything like this. Can we do this? What happens if I do this? Uh, yeah, of course, it's not a constructor. Yeah, doesn't work. We can't do this. So we can answer just. Maybe just is a bit of an unfortunate word here. Yeah. Only possible type level value is nothing. Considering maybe void and similar examples of kinds such as either void bool, why do you think void might be a useful kind? Uh, yeah. Um, mm, mm, mm. I don't know. I mean, why would I want to use maybe void? It's probably could be something like to specify that there's no possible value, but I'm not familiar enough with type level programming to know if this is even possible to do. Like, I don't know. Yeah, I'm not gonna even try. Who knows? Maybe to specify impossible types. Uh, I don't know. Maybe if we have some kind of type level encoded operation where you can divide numbers, if it makes any sense. Doesn't, but if it makes any sense. And then if I know that if I'm dividing some like uh, 0, then I know that I have to return something of type nothing, if it makes sense. But this will remain a mystery for now. 3. Oh, maybe that's where we're gonna use this. Write a JDT that holds strings or integers and keep track of how many strings are present. What? Uh-huh. I need to read this again. Write a JDT that holds strings or integers and keeps track of how many strings are present. Yeah, okay. I need to take a look at this. I feel. So here it encodes the vector using phantom type for length. And then a vector holds a value. Okay. Note that you might need more than nil and const this time. Okay, this is very interesting. Okay. So we are here holding two different values, right? We can have string or integer. So I guess we need to have two different cons, right? You might need more than nil and cons this time. I'm gonna assume that T is telling us that we need more. So like we need two cons. String cons. Which takes a string. Oh wait. I'm confused because this is parameterized only by the count. String and int list n, and then returns a string and list sn. I don't know, I'm confused. String and int. Okay, get an error. Int cons takes an int. So it only needs to keep track of how many strings are present. So I guess it returns the same length as the input. Okay, and then we have a nil, which is just string and int list z. No error here, which looks good. I'm not sure if it's correct. I assume so. So we have this string and int list. Which takes a string count nat of kind nat. So one issue I see here is this string and int. No, they're not existentials because these are concrete type. So let's try doing C first. Well, the type of the head function S and I head. This takes a string and int list of some n, which can be 0. So we can do s of n. So we are at least 1, and then returns either an int or a string. Uh, does this work? No. Sorry. Right s, left I. Yeah, it works. It works. Makes sense. So we are sure that we are not passing an empty list here. So we are not required to match on the empty list. And we can pass a value instead of having to wrap it into a maybe or doing other weird stuff. Update it to keep track of the count of strings and integers. Well, I mean, this looks very trivial. We'll just be adding a successor of n here. I think so. Or maybe it doesn't mean two separate counts. Let's try an int list. So takes a string count and then int count. Then we have a string count, which takes a string, and I need to change the name here. We need a tick. Compile or complain, int list as I return as a string and int list successor of s and I. Then we have an int cons, which takes an int, a string, and int list as I, list s, and successor of I. And then we have a string and int nil, which is just a string and int list of 0, 0. Missing an int here. Okay, and then we can write the new function. Yeah, it's a little weird that I flipped into string here compared to the data type. So the problem with this is that both counts need to be higher than 0. So I feel like we can have this, or maybe we could have we could have one of these two, or we could have weirder stuff like I don't know. These all look pretty bad to me. Probably this one is the best. 4. When we talked about JDTs, we discussed existentials. Now we could only know something about their value if the context told us. So yeah, we had this data showable, which has one constructor showable, and A is an existential here. So the only thing we can do is show these values. There's nothing else we can do. Write a JDT that holds something that may or may not be showable. And store this fact in the type level. Okay. I'm sad there's no one in chat because I really need help to go through these exercises. Just gonna go grab some water really quickly and I hope someone's here when I'm back. Okay, I'm back. Still no one here, I'm sad. So, let's start typing something and then we'll see. I'm confused. How is this bool gonna prove that this stuff is showable? Like, is the compiler just gonna trust us? What if it's not showable? Oh wait, so we're gonna have some constructor. So we're dealing with the existentials here. So for sure I have a type that's not gonna appear on the end result. Okay, I think is showable. No, sorry. Is not showable. Is showable. Show a maybe showable. True. Yeah. Okay. This looks reasonably correct to me. So we have a difference here is that we have this is showable of kind bool, which we return, and allows us to know if the type contained is showable or not from the type. Makes sense. Write a show instance for maybe showable. Your instance should not work unless the type is actually showable. Okay, I think this one is easier. Yes, this one works. Okay. So obviously we can't write the other instance. Let's try. Oops. Uh, yes, there is no show of a constraint, so we can do this. That's good. Thank you, GHC. Is it me or it's really hard to say GHC? GHC, I don't know. What if we wanted to generalize this to constrainable, such that it would work for any user supply constraint of kind constraint? How would the type change? What would the constructor look like? So many questions. Okay. Uh, uh, I don't know. uh, oh no, wait. A is a constraint. Uh, Wait. I'm so confused right now. Okay, let's just try writing something and I need to add constraint here. Use constraint kinds to permit this. Okay. Oh, these types check, but I honestly have no idea if it works or not. Uh, does it make any sense even? Maybe we can do something like this. This one makes little more sense to me. I don't know if it still works, because now we have a way to say that this constraint is about this type, which is the same type we're passing here. Let's try using it. It works. It's a miracle. This is very interesting. It's very, very interesting. The problem with these things is that I never know when to use it in my daily code, and then I forget about them completely. This looks something interesting, maybe for a library. I don't know. Okay. Let's move to 5. Recall our list type. Yeah, okay. Just a standard list. Use this to write a better hlist type that we had in the GADTs exercise. Bear in mind that at the type level, nil and const should be ticked. Remember also that at the type level, there's nothing weird about having a list of types. Let's open the exercise. Okay, so we have the hlist here written like this. And now we want to write a better one. So hnil is gonna be an hlist nil. Yes, no error here. And hcons is gonna be pretty similar. Oh, hi, there's a viewer. Thanks for joining. So this hcons will take an hlist of a certain length and return an hlist counts an. I don't know. Oh, hi, bot. You guys are getting pretty smart nowadays. Okay, I get no error here, so this is correct, probably. At least reasonably correct. I don't know if it makes sense. We can try writing these other exercises here and see if we can do that with our types. So, write a well-typed, maybe less implementation for the tail function on hlist. Okay, so let's call it htail. And this is gonna take an hlist cons head, let's call it success, and return an H list of access. Uh, okay, no error. This works. So we can pass this function our list, which is guaranteed to have at least one element, and so we can safely return the tail because we are guaranteed that there is a list. The empty list as a tail. I guess so. Yeah. And we don't need to pattern match on the empty list because obviously the type checker knows that it's impossible to get there. Could you write the take function? What would its type be? What would get in our way? What's take? Uh, is there like a description? Very useful. I'm assuming it takes the first n elements of a list. Let's try. Take 3. Yes, okay. So could you rewrite the take function? Let's try fashioning it out. H takes, take an int, should take an H list. We have no way to really guarantee that this list is the length of this list is higher than this int here at the type level. Because if, for example, this int is like 3, with a bit of pseudocode, let's use 1. Then we could just write that this list has to be counts x access and then return h list of counts x nil, if it makes sense. So we can do it this way because we have no way to know at the type level what's inside of this int. So I guess it's not possible to write it. Maybe with some advanced type level programming it's possible. I don't know. Maybe with type families it's possible to do this. I don't know. Or maybe we could do something like with a successor. So we have like s of z, which means 1. Then I can write this. Then I would have to write all the possible combinations. So if I have, yeah, no, it makes no sense. It's not possible. Hey, thanks for joining. Uh, some answers are gonna be we can't uh, because reasons. Okay, let's go to exercise number 6. Here's a boring data type. Blog action, add blog, add comment, delete comment. Okay, 2 of these actions, delete blog and delete comment, should be admin only. Extend the blog action type, perhaps with the GADT. to express at the type level whether the value is an admin-only operation. Remember that by switching on DataKinds, we access the promoted version of bool. Okay, I think I can do this. I'm pretty confident. I have it in the bag. So we have a data blog action is admin bool, where add blog is a blog action false, or maybe more than is admin is needs admin. Delete blog action true, add comment is a blog action false, and delete comment is a blog action true. So now we have encoded at the type level whether these actions can be done by a common user or if they need admin privilege. Okay. Yeah, this was exercise A. Write a blog action list type. Okay. This sounds a little trickier. So we need to write a blog action list type that requires all its members to be the same access level, admin or non-admin. I can't use this bool, I think, because this way they could be either true or false, so it would be pointless. Interesting. Let's try writing the constructors and let's see what this takes us. So we have a constructor which takes a list of blog actions. Okay, we can do this. And then returns blog action is safe. I don't know. This doesn't make much sense to me. Should I look at the solutions? I don't know. I don't know. It feels correct to me. If anyone in the chat knows that this is wrong, please tell me. Yeah. Anyways, I don't think we need JDTs here, right? I think we can write this. List is safe bool. I think we can do this. Yeah, it's actually a new type. Okay, interesting. Very mind-bending. Let's imagine that our requirements change And the lead comment is now available to a third role moderators. Could we use DataKinds to introduce the 3 roles at the type level and modify our type to keep track of this? Yeah. I think so. Need nothing. Need moderator or need admin. Yeah, I guess with this kind of stuff where I was trying to do some kind of type level equality check. Let's it was very interesting, but in the end I think it didn't make much sense. Let's see if I can find it. I'm logging in, yeah. Yeah, it's solder. No, it's solder. We need to go way back. Is it this one? Yeah, so add this, wait, it's too small. I tried to do this stuff here where I had functions which had the guarantee that, like, for example, I had these apartments which could be at a certain floor, and I could guarantee the type level that the floor was bigger than a certain value, which is very interesting. And I was thinking about this approach to work with authorization, like the exercise we're working right now. So instead of having a apartment floor, we're having an operation with a role level, and being able at type level to guarantee that actions were only performed by people with the appropriate role, which looks amazing. But I feel like there's a lot of work to go into it. Luckily, there's this Singletons library, which does much of the stuff for you, which is cool. But I still thought it was a bit overkill. Is this public? I guess so. No, it's secret. Can I make it public? Well, I'll look into it. Maybe I'll put it in the description later on. I'm confused. Isn't there a way to... Oh, it's public. Okay. So if I want to check it, this is very interesting. Oh, come on. I forgot I can paste from here to there. This sucks. Wait a second. Just gonna grab it from my Windows machine because I'm working with a virtual machine here. Okay, here it is. Here you can go check it. It's very interesting. If you're into type level programming, this library is very cool, the Singleton library. Anyways, let's go back to the exercise. So we can write this need level, which is gonna be incomplete because it can only match the level. So if I'm an admin, I think, and it needs a moderator level, it will still fail. We could do something like with that singleton example, but I don't want to do that right now. So then we can have a data blog action needs level. I guess we can call this just level. Maybe role. Makes more sense. User, oh come on. Moderator or admin. I'm not gonna write it all, but I think it works. So add blog. It's gonna be a blog action user. Then only users can add the blog. Admins and moderators can do that. So it's not really an optimal solution. Please stop me if you have any questions. 7. When we start thinking about type level Haskell, we inevitably end up thinking about singletons. Okay. Singleton types have a one-to-one value type correspondence. Only one value for each type. Only one type for each value. A simple example is unit, whose only value is unit. Bool is not a singleton because it has multiple values. We can, however, build a singleton type for bool. Okay, so we have this as bool, which takes a value of kind bool and has two constructors as false and as true. Okay, why is this a singleton? Singleton types have one-to-one value type correspondence. Only one value for each type. Okay, yeah. If the type is as bool true, the only value is as true. Of course, makes sense. So this is singleton. We have one value for one type and one type for one value. Write a singleton type for natural numbers. Can we? Is this a trick question? So we had naturals here. As 0. So this works because we have one value for one type, but I'm not entirely sure that this one will work. As suck. I don't know. Can we write this? Okay, I'm a little confused by this one. So let's go one step at a time. It's always the best solution. So in the end, want to be producing an SNAT of successor of some value, which we pass as an argument. Expected kind NAT, but n as kind type. Can I do this? No, I can't. It's expecting a type. Do I have to pass an S not n? Yeah, this compiles. I don't know. Sorry, wait a second. Okay, these type checks. I'm not sure if this is a singleton though. So here we have one value with one type. I don't know this. I don't know if we can tell it, say that this is a single type because n is a variable, right? I have no clue. I'm gonna check the solution afterwards for sure for this. Write a function that extracts a vector's length at the type level. Okay, let's go check back our vector data type. Is it here? No. I think it's here. Okay, so we have this vector, which has a length parameter and a type, the return type. Okay. I need help for this. I really have no idea how to do this. So we have this vector. We have the length which is encoded here. Okay, well, okay, I guess we can do this. So we can have a v-nil, which is at 0, or rather an S0. And then we have length of v-cons, where we have an head and a tail. And it's gonna be, now we can use a successor of the length of XS, right? Oh no. Biggest occurrence length. Let's change the name very briefly. Okay, this works. So we have this length function which takes a vector, which has a type level encoded length, and returns our natural singleton. The vector has two constructors, v-nil or v-count. So if it's v-nil, we know we can return the singleton for 0. If it's a vector of length greater than 0, we can just recursively return the successor to the tail of the vector. So for the last element, we end up with nil, so it's 0, and then we go back and add 1 with successor at each iteration, and we end up with the correct length. I think this is correct. Is proxy a singleton type? I think no, because there are multiple types with the same value. I'm not 100% sure on this. Oh wow. Okay. 8. We're almost at the end. Let's imagine we're writing some industry Haskell trademark, and we need to read and write to a file. To do this, we might write a data type to express our intentions. So we have a data program, which is parameterized on a result, and has some action. So open file, which returns a program result. Write file goes from string to program result. Read file, which takes a function, goes from string to program result, which is the file name. Close file and exit. We could then write a program like this to use our language. My app program bool, open file, write file, hey, read file, contents, if contents what, then write file, bug, exit false, and then let's close file, exit true. Okay. But wait, there's a bug. If the contents of the file equal what, we forget to close the file. Yeah, of course, because it only closes the file when the contents is not what. Okay. Ideally, we would like the compiler to help us. We could keep track of whether the file is open at the type level. We should not be allowed to open a file if another file is currently open. We should not be allowed to close a file unless the file is open. If we had this at the type level, the compiler should have been able to tell us that the branches of the if have different types, and this program should never have made it into production. We should also have to say in the type of my app that once the program is completed, the file will be closed. Improve the program type to keep track of whether the file is open. Make sure the constructor respects this flag. We shouldn't be able to read or write the file unless it's open. This exercise is a bit brain bending. Why? How could we make it more intuitive to write? Okay. So let's write a new program data type. So the only thing we need to keep track of is whether the file is open or not. Okay. So maybe we can do something like this. Let's start writing the code and see how it goes. So we have an open file constructor. We need to take a close file and returns a program with an open file, right? No, we need ticks. Very annoying. Okay, I can do it, I promise. Then we have write file, which needs string, program with an open file, and the file is still open after I wrote to it. Then we can have a read file, which takes a function that goes from string to we don't need these parentheses actually. And returns an open file. Program. The file is still open after read it. And then we have a close file, which takes a program with an open file. Returns a program with a close file. And then we have exit. Sorry. So the file has to be closed and we can finally return the result. Yeah, of course, I forgot to use the tick for program. confused by this exit here. Yes, it goes from result to our program. It's actually the opposite. Okay, I'm not entirely sure. It should probably work. Ba-bum. Improve the program type to keep track of whether a file is open. Make sure the constructors respect this flag. Shouldn't be able to read or write to the file unless it's open. This exercise is a bit brain bending. I'm not sure. Can we try writing this back? So we should have the guarantee that the file is closed at the end this way, right? Open file, write file. Okay, we're getting an error which looks good because it's telling us that the file is open, so this is an error. Let's try just let's try closing the file. This doesn't work. Let's try replicating the example there. Okay, read file, contents. Oh, come on. If contents equal what? then write file bug exit false, else close file, exit true. Okay, we get a lot of errors. Couldn't match false with true. I think there's something wrong going on here, and that I should be getting only one error, not all of this. So there's probably something wrong with the type I wrote. Let's try closing the file here. Ah, yeah, it doesn't work. Why is it not working? Why am I getting errors? Let's try something simpler. Simple. Okay, this compiles, but it shouldn't. I shouldn't be able to exit with an open file. So why is this not stopping me? So this exit true is a constructor which takes the result, which in our case is true, and returns a program false result. And this open file takes this program false result. Oh wait. Is this backwards? I don't know. I'm so confused. I need help. Okay, let's try this. Let's try opening and closing a file. Yeah, there's something very weird going on here. Let's read back here. We should not be allowed to open a file if another file is currently open. We should not be allowed to close a file unless a file is open. If we had this the type level, the compiler should have been able to tell us that the branches of the if have different types, and this program should never have made it to production. We should also have to say in the type of my app that once the program is completed, the file will be closed. Improve the program type to keep track of whether a file is open. Make sure the constructors respect this flag. We shouldn't be able to read or write to the file unless it's open. So my logic makes me say that open file takes something that's closed and opens it. Takes something that's closed and it opens it. That's not what it's happening because I'm getting errors. Interesting. Open file. Close file. Exit true. So I have this simple expression here, which doesn't type check. Couldn't match type false with true. Expected type program true bool, actual type program false bool. Okay, because I'm closing the file now. So this one is false. And now I get 2 errors instead of 1. Very, very nice. So couldn't match type false with true. Expected type program true bool. Actual type program false bool. This was program false result. Oh, close file takes a program true result. I think we really have to go backwards. Makes much sense to me. And now it compiles. Ah. I don't know. This compiles. I have no idea how it works, what's happening. I mean, obviously this one is the last operation. So this one has to actually return a closed file. And inside we have an open file. It's very brain bending. How could we make it more intuitive to write? I don't know. I think this is like free monad territory, which I never got. Maybe I should do one stream about free monads to try to understand them. Extra, write an interpreter for this program. Nothing to do with DataKinds, but a nice little problem. Not sure I want to do this now. I feel like this would take a lot of time. Yeah, I don't want to write all the file handling operations, opening and closing files. I don't think it should be too complex. Yeah, leave it for another time. It's getting late now. 9. Recall or vector type. Yeah, okay, so we have vector with a length parameter and the return type. Imagine we want to write the bang bang function for this vector, which is the function that takes an element at a given position. If we wanted to make this type safe and avoid maybe, we'd have to have a type that can only hold numbers smaller than some type level value. Implement this type. This might seem scary at first, but break it down into Z and S cases. That's all the hint you need. Okay. Uh, smaller than. I'm starting to get very tired. These exercises are very taxing for my brain. Okay. So implement this type. This might seem scary at first, but break it down into Z and S cases. That's all the hint you need. Okay. Smaller than, and then there is a limit, which is a nut. I don't know. I think I'm gonna stop here. There's smoke coming out of my head right now. Smaller than limit net. Okay, so we're gonna have a constructor, which may take something, and it's gonna return a smaller than, and then a natural. So this is the first step for sure. Okay, let's look at the function. Maybe it will give us an hint. Vector and a takes a smaller than n, returns an a. Okay, so can this vector be nil? I mean, there is nothing stopping us, right? Oh, this is hard. So we can have v-nil case. And then need, I mean, when it's v-nil, we need to have the guarantee. No, it actually can't happen because this is 0 and we can't have anything smaller than 0. So the type checker guarantees that this function is total and we are able to get an element. So the only case we can have is a vcount xxs, which has a certain length. Hmm. So we can have two cases. So if we have, I guess, a smaller than, which is at 0, then we can return x. Otherwise, and then we have a smaller successor and the successor of a certain number n. Then we can return of excess n. So this function kind of makes sense. So we can have a smaller than z constructor here and a smaller than s constructor. Let's see if the compiler helps us a little here. Oops. Parse error and pattern. We have values here, not types. Oh, it's so annoying. I'm not importing the prelude. Language, no, implicit prelude. Import prelude, hiding. Okay. Wildcard not allowed. So this one is definitely gonna be something like this, right? And what about this? If I think about the other operations we did with the naturals, it's gonna be a function which gonna have two values. I don't know, kind of randomly guessing right now. Doesn't work. Why is it not working? Maybe I'm looking at this in the wrong angle. Imagine we want to write, if we wanted to make this type safe and avoid maybe, we'd have to write a type that can only hold numbers smaller than some type level value. So this value has to be smaller than this value. Okay. So if my value is 0, this value is smaller than any value, right? So this could be the successor of n. We have this limit variable here. Do we have to do something with it? Does it make sense? I don't know. I have an idea. I need help. Help from anyone. I'm tired. I guess I'm gonna check the solutions. For the whole exercise. So in the repo, there's the answers branch. Now we can go in DataKinds and go check the exercises and check the solutions. Okay, new type integer width, method integer monoid. It's the same as what we wrote. It's the same, it's the same. No constructors. Okay, there are no answers for the theory questions. Fine. 3. String and int list, strings, ints, where string and il. Okay, it's the same as we did. It goes for the maybe either solution. Maybe is this too small? 4. Showable, maybe showable is showable bool. Yeah, looks the same. Looks the same. Constrainable, G from type to constraint, constraint seek. Okay, cool. Cool. This was good. This was correct. I wasn't hoping for it. H list types, list type, H list nil, H list access, H list context access. Okay. Yes, this was correct. You would have to apply take to the type level list to figure out the type of the result. We don't yet know how to do this, so it's possible, but we don't have the tools yet. Oh, Unison. It's a new language. It's pretty interesting. It's still in the alpha stage, so it's not very usable. It's a language where the code is immutable, so it's a little mind bending. But then when you write a function, it's converted to a hash, and that function is immutable. And then you can write other functions, change the function, and the hash changes. But other people code refers to that previous hash, so it's guaranteed to be always correct and working. And there are a lot of interesting concepts that comes out of that. You should go check it if you search for Unison language. It comes out. It's pretty interesting. I also have a video on YouTube where I try it if you want to check. I'm gonna paste my YouTube channel, or maybe just a video. Wait a second. Uh, so this is the video of me trying Unison. I had to stop at a certain point because I hit a bug with the compiler, which wasn't allowing me to proceed. It's really interesting. So yeah, definitely you can write any real program right now. But it's also very cool if you want to contribute to a new language, because there is a lot of very low hanging fruit. Like there is no standard library yet, more or less. So like I made a contribution by writing like filter and take for lists and stuff like that. Anyways, so 6, blog action. Okay. Yes, correct. Oh, okay, cool. Yeah, he used an array of roles here. So I had the problem that my function will only work matching the single role. He used arrays here, lists here, so you can match multiple roles. Makes sense. 7, sbool, snat. It's correct. Length is correct. No proxy. Yeah, it's not a singleton. I got it right. And height. Yeah, we have to write our code backwards. Our parameters are the programs that happens after the action. Open file is probably the nicest example of this. Not that we usually use a free-like structure to do this, as it's more intuitive. Yeah. Okay. Now we have the my app. Okay, yeah. We wrote the interpreter, which is pretty simple. We didn't write the actual IO functions, just printing stuff. 9. Okay, implement this type. Okay, so data smaller than limit not where z is smaller than the successor of any number. Uh, okay. Successor of a number smaller than x is a number smaller than a successor of x. Okay, I'm gonna trust you. Just wanna see what happens. So it's not doing anything with this limit. Interesting. The actual function b counts smaller than z. Okay, it compiles. I don't know why it works. Honestly, I have no idea. So why there's no link between this type here and everything that's happening here? Z is smaller than the successor of any number. So if I have a smaller than z, the value, then I'm smaller than anything. And this makes sense to me. If I have the value smaller than s, which takes a smaller than a value, then I'm smaller than the successor of the value. Okay, makes sense. This one makes sense too. But how is this limit, which means this n, is it because I'm using, no, doesn't make sense. I'm missing this link from this limit here and this any value here. Oh, I didn't do this one. Write a function that converts a smaller than n into a nat. So we have a 2 nat, which takes smaller than n. Yeah, this looks pretty straightforward. Okay, I'm gonna give up for today. I went much longer than I planned to, and I will go to sleep with the mystery of this SmallerThan, which is very, very confusing. I don't know. Thank you for watching. Good night or good whatever time is it there. You too.